So in the last video we talked about uh, the definition of continuity, and the definition of continuity had three conditions. The first condition was f of c is defined. The second is the limit must exist at x equals c, and the limit and the point must be the same. So we're going to go ahead and apply the definition for these next examples, and we're going to go ahead and define if the following examples are continuous at the indicated x value. So we're going to use the definition to determine if f of x is continuous at the x value that's indicated here. So we're going to go ahead and analyze this function. We have a rational function, but I noticed that this rational function can be rewritten in a different way. So we know that the top can be factored because it's the difference of two squares. So x minus 2, x plus 2, all over x minus 2. Now, from the very beginning, if we plug in 2 into this function, we see that we get a 0 over 0. So we know this function cannot be continuous. Anytime we get a 0 over 0, we have a point discontinuity. So let me go ahead and proceed with the function that I had written below. I can cancel out the factors of x minus 2, leaving me with x plus 2. So we really just have a linear function that crosses the y-axis at y equals 2. So it's a rise and run of 1, and then at 1, 2, we have an open dot, and then we have the remaining of the linear function. And clearly, this function is not continuous because of this open hole. So this function failed the first condition. So f of x is not continuous because f of 2 is not defined. In other words, it's kind of like a formal way of saying it failed the first condition. Now, this is the way you want to explain it when you're taking your AP exam. So when you're asked to provide the rationale, you want to write a complete sentence, and then use evidence from your problem, and use the rationale from the definition of the continuity. So letter B, we have a rational function again, and this rational function, if you remember your parent functions, has an asymptote at x equals 3 because x cannot be 3. Know that from the left it looks like this, and from the right it looks like that. Okay, so this function is not continuous. So f of x is not continuous, and then because, well, we know it's not continuous because of the asymptote, but really it's not continuous because f of 3 is undefined. There's no point here at this x equals 3. There's an asymptote, so we're going to say because f of 3 is not, is not defined. Letter C. Letter C, we have an absolute value rational function. So the way we do this is that we have to use the definition of an absolute value function to make this to a piecewise. So we know that a absolute value function has to be split into two parts, a positive version and a negative version. So here's the positive version, and then here is the negative version. And then here are the domains for the corresponding rational functions. Okay, well, this can be simplified. That's just a positive 1, and that's just a negative 1. So I really just have two constant functions. So I have 1 here, negative 1 here, and then 1, 2, 3. So from x equals 3 and beyond, I have a positive 1 constant, and from x equals, well, not exactly x equals 2, but when x is less than 3, I have a negative constant function. So f of x is not continuous because, well, let's analyze why. The point exists. F of 3 is defined as 1, but the limit does not exist. So we're going to say because the limit as x approaches 3 of f of x does not exist. So this is the case where we have condition 2 failing. Letter D. Letter D, we have two linear functions. We have x plus 2 and 2 minus x. So we have these two linear functions that share the same y-intercept, except the left side of this function is a positive linear going up till 1. So I'm going to say it's about right there. But notice it's not including 1, so we're going to draw an open dot. The right side of this function is 2 minus x. So it's going to look something like this. So there's the function. Something like that. And then going down like that. Okay? So it's going down because of the negative x. It's got a negative slope. So right away, f of x is not continuous. And why? Well, because first of all, none of these points are defined. Because f of 1 is not defined. Letter E. Letter E, we have here the parabola. We have a parabola that's shifted up 1 unit, so it's the basic quadratic function. And we want to analyze the function at x equals 1. So here's x equals 1. Well, let me go ahead and check the conditions of definition of continuity. Does the point exist at 1? Well, yes it does, because if I plug in 1 into the function, I get 1 squared plus 1, which is 2. So the first condition passes. The second condition, does the limit exist? Well, we see that we have this parabola that's always continuous no matter what, so the limit does exist. So the limit as x approaches 1 of f of x exists. And then we need to check the last condition, which is, does the limit of the function equal the function value at that same x? Well, the limit does exist, and it seems to be approaching the same function value, which is 2. So the limit as x approaches x approaches 1 of f of x is also equal to f of 1, which is 2. So continuous. Okay. Oops. Alright. Continuous. Alright. For the last example, we have a rational function, but we notice that each of these terms have a common factor of x. So I can write this like that. I can cross out the x's, and now I have 1 over x minus 3, which is the same graph as letter B. So letter B looks like this. We have an asymptote. We have the rational function behaving this way around x equals 3. Now, the only thing is that at x equals 0, if I were to plug in 0 right now the way it was, I have a problem. I get 0 over 0, and 0 over 0 implies point discontinuity, which means that there's an open hole here. Whatever the function value is, or whatever it's supposed to be, there's an open hole there. So f of x is not continuous. because f of 0 is not defined. Okay, well, this concludes our lesson on continuity, and I'll see you guys in the next video.